Hey, what's going on, guys? It is your average programmer here, and today we are going to be talking about the bubble sort algorithm. Now, if you don't know what the bubble sort algorithm is, stay tuned because I'm going to explain everything there is to know about the bubble sort algorithm. Now, if you're a computer science student, or if you want to become a software engineer in general, or any kind of data scientist, this is a really good introductory algorithm for becoming a software engineer or data scientist. And I say that because this is a basic fundamental algorithm to many different algorithms. This sorting algorithm will give you insight into how an algorithm works. And the best way to start knowing something is to start simple, to start small. And that's exactly what this algorithm is. There's not much complexity to it. So I'm going to explain it to you as best as I could, and hopefully you get a grasp of it. If not, you can leave a comment down in the comment section, and I will get back to you for sure. So let's go ahead into what a bubble sort algorithm is. A bubble sort algorithm is a simple sorting algorithm. So if you have a collection of numbers that are out of order, this algorithm sorts them for you. Now, it is a comparison-based algorithm, which means that it compares every element to its adjacent element, to its next element. So if you have an element at index 0, it will compare the element at index 0 to the element at index 1. And if the element at index 0 is greater than the element at index 1, a swap is going to happen. As we see here, once the largest element is sent to the end of the array, the index is reset to 0. The reason it's called the bubble sort algorithm is because it takes the largest element and it bubbles it up to the end of the array. And then it resets to 0 and it starts over again with the algorithm. The process starts all over again. It takes the next largest element and bubbles it up to the index less than the largest element. And eventually all of your elements are going to be in order. All of your numbers are going to be in order. So before we head into Visual Studio Code, I prepared a little presentation for you. Hopefully you like it. Prepared a cool little presentation for you. So let's see here. Let's say we've got an array of these different numbers right here, 7, 34, 10, 0, and 1. We've got an array of these different elements, a collection of these different numbers. And as you can see here, these are the position of the elements. Index 0, index 1, index 2, 3, and 4. So let's say we've got this array. This is what the bubble sort algorithm does. It checks the first element, which is 7 in this case. It checks 7, and then it compares 7. Let me grab this point over here. It compares 7 to the element next to it. So it compares 7 to 34. Is 7 greater than 34? No. So it's perfectly fine. So we take the index and we move up 1. So now we're at index 1. Is the number at index 1, which is 34, greater than 10? Then it compares those two elements. Let me grab this again. Is the number at index 1 greater than the number next to it, which is at index 2, which is 10? Yes. So a swap happens. So we take 34 and we swap it with 10. So now 10 and 34 are swapped. So now we increment the index. So now we're at index 2. So now it compares the element at index 2 to the element next to it, which is at index 3, which is 0. So now it says, is the element at index 2, which is 34, greater than the element at index 0? And yes, this is true. So again, a swap happens. So we swap the elements 34 and 0. And then, as you might guess, the index is incremented. Now we compare the element at index 3 to its adjacent element, which is the 1. So is the element at index 3 greater than the element at index 1? Yes. So again, a swap happens. So as you can see, 34 went from being at index 1 to being the last element in the index, which is why it is called the bubble sorting algorithm, because 34 is bubbled up to the last element. And then after we do this, index is reset back to 0 because we've proven that 34 is larger than every other element. Because we've bubbled it up, we've compared it to every element, and it's bubbled up to the last element. So now we do not worry about the last element. Let me grab a Sharpie here, or crayon, whatever it is. Let's see, crayon. And then we no longer have to worry about this element at index 4 because we've proven that it's the largest element. So now index 4 exists, but we're not worrying about it right now. So now again, we reset everything. Is the element at index 1 greater than the element at index, or the element at index 0 greater than the element at index 1? No. So we increment. Is the element at index 1 greater than the element at index 2? Yes. So a swap happens. 10 is greater than 0. So we take 10 and then we swap it with 0. So as you can see, 0 is going to the front, while the biggest numbers are going to the back. The smallest numbers are going to the front, while the biggest numbers are going to the back. So is the element at index 2 greater than the element, sorry, I forgot to increment. Is the element at index 2 greater than the element at index 1, or index 3, sorry? Yes. So again, a swap happens. As you can see here, we're continuously comparing and swapping if necessary. We're continuously comparing and swapping if necessary. So again, index is reset, and we cross out index 3 because we've proven it's the next largest element. We know for sure 34 is the largest, but we also know that 10 is the next largest. So we don't worry about that. And we keep comparing. 7 larger than 0, yes. Swap. As you can see, 0 is now in the front. Is 7 larger than, we increment index. Is the element at index 1 larger than the element at index 2? Yes. So again, we swap. Again, we're continuously swapping, comparing and swapping. So we've swapped these two elements now. We reset everything and we compare. Oh, let me redo that. So now reset to 0 and we cross out index 2 because we've proven it is the third largest element. We do not need to worry about this anymore. Is the element at index 0 larger than the element at index 1? Its adjacent element? No. So we are all set. We've bubbled all the largest numbers to the top, and we've brought the smallest numbers to the front. That is the whole theory or the whole concept on the bubble sort algorithm. Now we're going to jump into Visual Studio Code and we're going to code up this bubble sorting algorithm. It doesn't take much time and it's not complex. All I need you to do is follow along, and you can code this along if you want. But I want to make sure you understand it, so be sure to pay attention because I want to make sure you understand it and you have a good grasp on this algorithm, because this is one of the basic algorithms. And if you can understand this, you can pretty much get a grasp of any other algorithm there is. This is just a stepping stone for every other algorithm. So again, we're going to jump into Visual Studio Code. I will meet you there. See you. All right, guys, now that I've started up Visual Studio, we're going to go ahead and create a new project, a console application with the .NET Core. Let's go ahead and name it BubbleSort. Again, you can name it anything you want, but I'm going to name mine BubbleSort. Let's go ahead and create that project. And I hope you all are doing okay. Hope you all are staying safe out there. Let's go ahead and give this a second to load up. So again, I hope you had a good grasp on the BubbleSort algorithm from the small presentation that I showed you, because now we're going to be coding up the algorithm. So let's go ahead And we don't need to create an extra class, a separate class for this. We're just going to create it below this main method. So we're going to say public static. Oh, let me fix my keyboard. This thing is wobbly. Create a static class. There we go. Sorry about that. Or a static method, sorry. Static, we are going to return an array of integers. Again, this is the syntax for an array of integers. We're going to call it BubbleSort. And this method, of course, is going to take an array of integers. We're going to call it random array. I'm going to call it random array. So let's go ahead and perform some modifications to this method. So first, we're going to declare an temporary integer variable named temp. You can call it whatever you want, but this is going to be our temporary variable, and I'm going to show you why. I'm going to explain why. So, of course, as you know, we're going to have to loop through this array. So we're going to create a for loop. So for, we're going to use simple variables I and j. This is going to be a double for loop, a nested for loop. I is less than, we're going to take this array, random array.length. Random array.length. And for as long as I is less than this random array, I spelled it wrong, we want to increment I plus plus. Now we're going to enter this for loop. We're going to write another for loop. So this for loop is to loop through each element in the array. So we're going to have an array, we're going to loop through each element. However many elements there are, we're going to loop through each one. And for the second for loop, we're going to take each individual element and compare it with each element that we loop through, which is why we're nesting this for loop. So we're going to take this inner loop, we're going to call it j, the index j, and we want it one less than this outer loop, because again, we're going to compare it to its adjacent element. Now, if we get to the last element and we compare it to its adjacent element, we're going to get an out of bounds exception, because after the last element, there is no element next to it, which is why we want to call this, or want to compare this to random array dot length minus one less than this loop, this outer loop, because again, once we get to the last element, there is no element next to it. So the element before the last element, we want to compare that to the last element. I know it's a bit of a mind-boggling thing, but I'm going to show you. I'll explain everything to you. I want to increment j by 1. So let's enter this second for loop, this nested for loop. Let's go ahead and declare an if statement, because we're going to compare these elements. And in this if statement block, we are going to say if array, random array, if the index at random array at the current index, if the number at the current index of our array is greater than the index of the element next to it, j plus 1, we want to perform some switches, some modifications. So if the element at the current index is greater than the element next to it, greater than the element at the index next to it, we want to do some swaps. Remember, I told you when we had this here, 34 was over here. So where's this pin? So if 0 were to be greater than the element next to it, we would perform a swap, which is what we're saying here. If this element that we're currently at is greater than the element next to it, we want to perform a swap, which is what we're going to write over here. So we're going to make use of this temp variable. Again, I'm going to explain why temp var equals random array, the element at the current index of this array. And we want to say random array the element next to it, j plus 1. We want to set that equal, element j, we want to set that equal to element j plus 1. This is where the swap happens. And we want to set random array j plus 1, which is the element next to it, equal to temp var. So here's why we use this temporary variable. Let me comment it out really quickly. So we have the element at index j, which is the current element that we're on. If we set the element at index j, the current element, to its next element, then we lose the memory address of this element. So the value is now gone. The value has diminished. We no longer have this value because we've reset the value from having the value at this current index to the value of the index next to it. So let's go back into our presentation here. So let's say we have 0, 0. Let's say 0 is greater than -1. We had a -1 right here. If we just set this element at index 0 to -1, and then what are we going to set index 1 to? Because we've lost the memory address of 0, we've lost the value of the index 0. 0 is now gone. So we have to use this temporary variable to first set the element at our current index to it. That is the reason why we have this temporary variable. We don't want to lose the value of our current element. And then we set the value at our current element to the element next to it. Then we set the value of the element next to it to this temporary variable, which holds the value of the current element. Now that's why we use the temporary variable. And when we break out of this outer loop here, we are going to return random array. Oh, what did I do here? We're going to return this random array. So once we've taken in this array, we've modified this array to sort it. We've done some sorting with this array. We've done some comparison and swapping. Done some comparing and swapping. We want to return the modified array. So up here, let's go ahead and create our array. Let me zoom in here. Let's say we've got an array called array 1. Doesn't matter what you call it. Equal to new integer array. And in here, we're going to use the same values we had. We had 34. Oh, I lost the value. So let's just say we had 7, 34, I believe 0, then 10. 0, 10, 1. I believe 1 was at the end. But this is an unsorted array. That's what matters most. This is an unsorted array. As you can tell, 34 is the largest number, it's supposed to be in the back. 0 is the smallest number, it's supposed to be in the front. Now we're going to console.writeLine, or console.write, sorry. Right here. I'm going to leave this blank for now. But we are going to call our BubbleSort algorithm. Actually, we're going to loop through this array first. We're going to print out these numbers. And we can do that using a for each loop. So for each var num in this array 1 that we have, array 1, we want to print out the numbers. Right. Console.write num. We'll put a comma after each number. So up here, we're going to write before bubble sort. And I'm sorry for making this video so long, but I want to get the point across of this bubble sort algorithm. I want to explain in depth what this algorithm does. So we're going to print out our numbers from this unsorted array. And print out all the numbers. As you can see here, it takes a sec. So before bubble sort, this is the numbers that we have, this unsorted array. We have all of this unsorted. So now we're going to sort everything. We're going to call the bubble sort method that we created. And again, we perform comparisons and swaps. We'll call the bubble sort method bubble sort, and we're going to pass in array 1. Now when you perform some kind of manipulation to an array, it returns a new array. So we have to set this to a new variable. Integer array called array2 equals bubble sort array 1, sorted version of array 1. So array 2 is the sorted version of array 1 because we've passed it into this bubble sort method. So now we're going to do a for each statement again. For each, and I know this is becoming redundant, but again, I just want to get the point across. For our num in array 2 now, not array 1, but array 2, we want to console.write each number. Gotta put this inside parentheses. So we've got our unsorted array, as I showed you earlier, printed out to the console, an array of unsorted numbers. We've printed out each number individually, and now we've passed this array, this unsorted array, into the bubble sort method, and we've printed out each number. So we're going to see what happens. Let's see what happens with this if we get it right. Oh, forgot to write after console dot write after bubble sort. After bubble sort, so we're console.write lining each number. So let's go ahead and see what we get. And I forgot to do a console.write line under here, just so they're on different lines. Let's see what we get. As you can see here, oh my gosh, this looks ugly. Let me all right, here we go. As you can see here, we have our sorted list of numbers. So before bubble sort, we had this. We had 734, 0, 10, 1, obviously unsorted. Now after bubble sort, we have 0 in the front, smallest number, the next smallest number 1, the next smallest number 7, then 10 and 34. As you can see, our bubble sorting algorithm, our bubble sorting method worked. So that is the entire gist of the bubble sorting algorithm. Hopefully it makes sense to you. I hope I didn't talk too much. And the reason I did, if I did, is because I'm trying to get the point across, trying to get you to understand the fundamentals of an algorithm. And this is a fairly simple algorithm. So that's exactly why I wanted to go in depth with it. And we can actually pass in any number here. Let's pass in 1,000. Let's pass in random numbers here. And let's get the same results. We're going to pass in these random numbers. I'm going to print out the unsorted array, and we're going to print out the sorted array. So 900 to, it doesn't matter what you pass in, 321. Now let's go ahead and call same method, same procedure. before bubble sort, we've got 1,000 all the way in the front, which is obviously less than or greater than 365. This is a complete mess of unsorted numbers. But after using the bubble sorting algorithm, the bubble sorting method that we created, it looks a lot better. We've got everything in order. We've got 2, 235, 321, 365, and it's obviously sorted because we created this bubble sorting method using the bubble sort algorithm. So if you like this video, be sure to hit a like down below. I hope you understood it. If you did not understand any part about this video, be sure to comment down below and I will get back to you. If you like this video, hit the like. If you want to subscribe, if you feel like you like this channel, you like the way I explain things, please be sure to subscribe and turn on your notification bell. I hope to see you again. You all have a good day. Thank you for watching.